I think he knows you're not.
Oh.
Ooh, our
What? You didn't wait till you're gonna say other.
quiz is graded.
Are your quizzes graded? No, I'm sorry.
It's okay. It just makes me so anxious.
I didn't get home till 10 o'clock last night, so I chose to go to sleep.
I know I missed the last one.
Well, actually, I chose to play on my phone for 15 minutes and then go to sleep.
I feel bad.
I know for a fact I missed
That, I don't know. I literally every single night I just lay on my phone. Like last night, I think I was on it until like 11:30 or 12. I don't know why I make myself stay up. Like I make myself because I just sit there and I'm not even really looking at or reading.
I know last night I was
scroll.
watching film for like an hour before going to bed. Just couldn't.
Alright, so before we move on to the next section, okay, so first off, I will try to have your quizzes graded and your test graded and homework graded all tomorrow. That's gonna be my goal tonight. So, depending on I have a good night, that's my goal.
If not,
I believe in
really
you,
okay.
Miss Whaley.
We'll be okay if you don't get it done.
It'll be okay?
I don't know if Hannah will, but everybody else will.
How about this? Regardless, I'll get your homework and your quiz done. I may not have your test done. Will that be fair?
Yes.
Okay. So, I don't know what I was gonna say. Before we can go to this next section, the next section is over derivatives of trig functions. They take a break and then they literally like review like the whole semester of trigonometry in one section. Okay, so I'm gonna hit on like the big points, and then if you guys have questions, we can go from there. And I'm assuming you have 5 questions on your homework, so I didn't want to like go over every little thing. I'm just gonna talk about what do you guys remember about trig. Homework from 3-2 is due tomorrow by the end of the day. So you can turn it into me or you can turn it into Mr. Urban. If I'm not in here, you can just put it in my tray. Okay? Okay, what do you remember about trig?
SOHCAHTOA.
Okay, so what's SOHCAHTOA?
Sine.
Opposite. No, that's
Okay, when can you use it?
triangles.
Right.
Like,
They have to be 90-degree triangles.
yeah, like a make.
How about the TOA, angle and tangent? Do I need to write all the reciprocal ones, or do you remember them?
You might want to go.
Those are-
Cosecant, secant, and then cotangent.
Okay, so cosecant is reciprocal sine. Secant is the reciprocal cosine.
I'm really mad at whoever decided which words go where.
Yeah.
Because they don't match up.
Cotangent is reciprocal tangent. Okay, so you remember, and you can only use these on right triangles. So it has to be a right triangle, or it can be a perfect angle in the first quadrant. So if that's your angle. Remember, this would be the adjacent. That would be your opposite. And this would be your hypotenuse. Okay? What else do you remember about trig?
Circle.
The unit circle, okay, so you remember you have your perfect angles, do you remember what they are? Do you remember what the first quadrants are?
1.
0,
30.
30,
45.
okay.
And 90.
Do you remember what their points are?
0.
0 is 1, 0.
It's 1, 0.
Is it
Okay, and
square
then
root of
30.
Square root of
2,
3 over 2, square root of 2 over 2.
This
Or,
is
yeah.
square root of 3 over 2 1/2, good.
Square root of 2 over 2, square root of 2 over 2.
Okay, good.
That one.
Then 60 is
1 over 2, square root of 3 over 2.
1 over 2, square root of 3 over 2.
0.
Okay, so you have some unit circle stuff on there. wasn't a right triangle, wasn't on your unit circle, do you remember the other way we found everything?
That's a good question.
No.
Isn't there, I guess,
There's an equation that uses like for the radius.
No.
Okay. Your X, Y, and R.
Yeah.
Okay, so.
Oh, it's got K's in it, doesn't it?
It's just a cake.
No, that's like circles.
Oh, okay.
So these are your perfect angles.
Wait, this goes with the triangles?
No, I'm sorry, like, so we did right triangles, you done unit circle, and then we did the ones where you had X, Y, and R.
Okay.
Okay, remember R was the square root of X squared plus Y squared? So
Yeah.
sine is Y, right? But if it's not 1, sine is Y over R. So then cosine was X over R. And tangent,
I do not remember that.
you remember this? Y over X.
Oh, well, it just makes sense as a Pythagorean.
And then, yeah, it does, all comes together, doesn't it?
Yeah.
And then sine is, cosecant is reciprocal sine. Secant is the reciprocal cosine. And cotangent's reciprocal of tangent.
I remember doing this. Like, I remember writing it on my unit circle plate.
That is all like chapter 4 stuff. Oh, there's more chapter 4 stuff that you learned, but.
Did we do, like, logs or something with E's?
We did, but not in trigonometry, we did it in pre-calc.
Okay.
Okay, do you remember how to convert from radians to degrees?
Oh, it's over
180 over 5.
Okay, so when you're converting, depending on what you want, you're either gonna multiply by pi over 180, or you're gonna multiply by 180 over pi. So this one's if you're going to radians. This one's if you're going to degrees. What else? I don't know. This way, like, I already know this too. You should already know this. When you're drawing an angle, if it's in standard position, so standard position, do you remember where you start?
drawing a circle.
Just, you start here, if you're drawing an angle. This would be your initial side. And then let's say your angle ends over here. That is your measurement. And this is your terminal side.
That's not.
What about, do you remember how to find arc length? Like that would be your arc length right there. I think they use A in your book. They do. They use A as arc length. And then they still use R as radius. And theta as your angle. And on, when you're finding arc length, or finding something with arc length, your angle has to be in radians first. Okay, so the formula is arc length equals the radius times the angle. talk about all the formulas? Did Ms. Draper give you guys like a formula sheet at all you could use? Like I had the same ones we used like last year. Okay. I don't have the unit circle in here, I could recopy the unit circle if I need to. But I wasn't gonna make you write down like the sum to product, product to sum, multiple angles, the reciprocal, the Pythagorean. It doesn't make sense to write all those out when you have a formula sheet that does it. I would say your big thing to remember, sorry, I'm trying to find. On the formula sheet, do you remember like about like proving identities? Okay.
I remember doing it, I just don't remember how to do it.
Okay, well, you'll, like, using your reciprocal, your quotient, and Pythagorean, you'll be using those still in calculus. Okay. I mean, you'll use some of the other ones, but just remembering which ones are reciprocals of each other, which we just talked about here. Your quotient identities, you have 2 of those. So, like, remember that tangent. Okay, if that's y over x, that's the same thing as sine over cosine. And these are on that paper. And then cotangent's the reciprocal of that. So cosine over sine. And then you had your Pythagorean identities, which the biggest one that's always used is cosine squared plus sine squared equals 1. Okay, so this is, I know like, been doing this whole semester in about 15 minutes. Okay, I want to go through your homework directions, and then if you guys want to do an example, we can do like one of the odd ones or even ones or something that would go along with it. That way you understand what you're supposed to do. Okay? And the homework numbers, I don't know if this is like on purpose, are the exact same homework numbers that you had for 3-2. So I don't know if it's like, I'm assuming it's not a mistake. I don't know, I just took yours of paper. Alright.
Will we have time to go over a couple questions?
From last night's homework?
Yeah.
Sure.
I tried doing 46 and 48, but I think those are my last 2.
Okay. Okay, so with your homework, are we okay on converting from degrees to radians, radians to degrees? Because that's like the first part. Okay. In the next part, you have a question about arc length. So just use your formula. Okay. Then drawing angles in standard position. If it's negative, so going this way is positive angle. What's a negative angle? Okay, you're still starting here, but you're going this way for a negative angle. Okay? So if you're going like negative 30, that's what I was going to draw. That would be here, but I'm going to go backwards 30 degrees. That'll be my angle. Okay. Everybody's okay on that? Okay, then on 23 and 27, it says find the exact trig ratios for the angle. That's using your unit circle. guys are real quiet.
What does that mean, like trigonometric ratios?
That means like find the sine at that value. Find the cosine at that value.
Oh, so to find all 6?
Yes. Okay, remember if it's just on the unit circle, x is just cosine, y is sine. You don't have to divide by the r's. Okay? Whatever x is tangent. So just need to find all the answers of what it is. So if I said, if it was like 30 degrees, you would have your cosine is square root of 3 over 2, your sine is a half. Then when I find my tangent, I take this divided by that, so square root of 3 over 3, and then I would do my other 3, which are the reciprocals. Okay, then 30 and 34, that's when you're using your x, y, and r, because those are not the perfect ones, okay? And then that part that's over there in the inequality, that just tells you what quadrant you're in. So do you remember all your quadrants? Like 0, pi over 2, pi, 3 pi over 2, and 2 pi. This quadrant, x is positive, y is positive. X is negative, y is positive. Negative, negative, positive, negative. Quadrant 1, 2, 3, 4. Okay, so you're using x, y, and r on 30 and 34. 35, you're using SOHCAHTOA. 41's a proof. Okay. And then you're doing proving the identities on the last 2. Would you rather just try it and then be like, yeah, I totally don't get this, like at least go through them, or would you rather me just like pick a random example that falls in the category?
Can we do
Either way.
like one of the ones that are like prove the identities? I don't know what that means. Like,
Yeah. Which one you want to do?
I don't care.
How about 45? I like that's a good one.
Or 46.
No, this 46 is not real tough one, right?
Oh, that means that was great.
How would you start 46 though?
Let's.
Oh, it's the,
It's
okay.
parentheses squared, so you would distribute it, right? Like write it twice and FOIL it out.
And then it equals 1.
So you just have to get them equal on both sides of the networks?
Yeah.
Oh, I remember doing that. That makes sense.
So like if I do 45. And your identities, majority of the ones that you'll use on that paper are the reciprocal, quotient, and Pythagorean. Can you use like the double angle or power reducing or all the other ones? You can, yeah. It's just not used as often. Okay, so like on this one, if I want the left-hand side to equal cosine, so I can change cotangent to be cosine over sine. And then the sines cancel. And this side gives me cosine, that side's cosine. So I'm done.
Good at it.
I don't remember
I
this
like
being
doing
easy.
I liked it.
Yeah, that was definitely a
I just
super
didn't
easy
realize
one.
what- I didn't know.
You have super easy ones, but here's the thing, guys. When you first learned it, it was really, really hard because you've never done it before. Then it gets easier because then it's like this gets stored in your brain. So when you recall it back, it's like, oh, that's a lot easier.
So like when you prove
Some of them
were really hard.
It was kind of easy in the first
How would
place.
you do that?
If I were doing what?
Like if you were to prove each equation, like what would you have to do to make it proved?
Prove that those are that those formulas exist. So this one says prove equation 18. If you go through, there's all those formulas that are on your formula sheet. You're supposed to prove that it's how can we get that formula from what we know?
Oh, all from.
I'm really gonna struggle with
So like
that.
how do I know like I don't know which one you're doing, but like how would I know that tangent of x plus y is tangent x plus tangent y over 1 minus tangent x tangent y?
We have to do 41.
Yeah, you have to do 41, which is, what equations?
18.
18.
C.
So you gotta prove that sine x cosine y equals 1/2. So you're trying to figure out how can we go, with everything you know, how can you go from the left-hand side to the right-hand
So you're
side?
supposed to use like the other stuff to like make the side equal?
You're, essentially, yes. How do I know that this is gonna give me that?
It's like you have to like do stuff to it to make it equal to the other side.
Proving that is true, yes.
Wait, what's equation?
And you can always start with the right-hand side and work your way to the left.
You have to go back a page. It's
You can
on
do
page
backwards.
30.
And like, okay, so I know if I get a cotangent, I know, well, I could put cosine over sine. I don't have to put cosine over sine, but that's something that we know exists.
Yeah.
Okay? Do the best you can on those.
Do B and C.
Huh?
You have to do all three of them.
No, just A. Just kidding, yeah, we do.
Yeah,
Oh, I definitely was skipped 18 feet. I thought that was a different question.
Yeah, I did too.
Okay, why don't I let you guys, I'll answer your questions, we'll do next. Why don't you guys try these, and then I know what I need to go over more, tomorrow, okay? Okay, what was your homework question? 40 something.
6. And 48.
46 and 48. I will do all this, I'll do all the trick homework tonight, so. Okay, so 46, you're finding the derivative, is what that's saying to do? I think what we're gonna do on your final, like your real test during the final exam time, is, I think we're gonna stop after section 3.3, which is trig functions, because we only have next week. So it's just doing derivative of trig functions, and we'll pick up with chain rule and manual. Okay?
So-
Yes.
Christmas
I need to
Day.
like read your test though to figure that out. So I told them I'm gonna try it tonight, and I will definitely have your quizzes and your homework graded tonight. I may not get to a test till this weekend, but if I'm gonna try to get them done tonight. How was the orchestra thing?
It was good. It was a little weird, but I liked it.
Okay.
My parents didn't like it as much.
Explain.
I mean, it was just like a weird mix of things. Like you heard one type of song, and then like next thing you know, it's like a completely other type of song. Like it was just weird, but it was good.
Okay.
Oh,
All right. So, sorry.
Go ahead, go ahead. It's okay.
I'm just gonna talk to her about the problem.
That's fine.
Okay. So what that's telling you to do, because it looks really, you're finding the derivative of this function h of x over x when x is 2. Does that make sense what I'm saying? Okay, so if I'm finding the derivative of h of x over x, we're gonna use a quotient rule, correct? Okay, so what's the quotient rule say?
G of x times the derivative of f of x minus f of x times the derivative of g of x.
Okay. Does that make sense what I just did right there? Because we did, so told me g of x times the derivative of f of x minus f of x times the derivative, but I knew the derivative of x is 1, but we don't know what h of x is, okay? Over, this g of x squared, correct? Okay, so that would be over x squared. Okay, and then in the problem, it tells you, because you're going to put 2 in for x, but it tells you what h of 2 is and what h prime of 2 is. So then I'm going to put all those numbers in. So the first one just says x, so that would be a 2. Okay, but the second one is it says I want to find h prime of 2. Well, it says that h prime of 2 is what? So I just put a -3 here. Minus, and then this one's h of x, so h of 2 is 4. just got that from what it said in the problem, okay? Times 1 over, and then putting 2 in for x, so 2 squared. Okay, so then if I simplify, this would be -6 minus 4 over 4, which is -10 over 4, which is -5 over 2.
That looks so simple now.
It's just like, it looks confusing, like when you're trying to figure out what you're supposed to do. The other one was 48, right? Okay, so 48, you're given what f of 2 is, and you're given the derivative is, but you're asked to find the second derivative of 2. So if I know that the first derivative is,
Like square root of x.
thanks. Okay, now I have to find the second derivative at 2, so I have to find the second derivative. So you use the product rule. So what does the product rule say we're going to do?
F of x times the derivative of g of x plus g of x times the derivative of f of x.
Okay. That's what I did. I just, as you said it, I wrote them out. Okay. Now you're finding when x is 2, so I can put 2's in for the x's. So this would be 2 squared. But then I don't know, so I have to go back and look at my directions, and it says f prime of 2 is we don't know yet. Hang on, I'll show you how to find it. Okay. I don't know what this is right now. We'll talk about it in just a second. And then f of 2 is 10 times, and this would be 2 times 2? 4. Okay? How would I find this number right here? Anyone know?
What is it, f?
That's f prime of x. That's f prime of 2. Okay, we were
Sure.
given the f prime equation, correct? So why don't we just use this to solve it? So this would be 2 squared times, we know f of 2 is what, was it 10?
Yeah.
10. So this would be 4 times 10, which is 40. That's this right here. So it gave us the equation for the derivative, but it didn't give us what f of 2 is, so we actually had to put the 2 in for here, and then it gave us what this number was, which was 10. And then I just multiply. So 4 times 40 plus 10 times 4 will be 160, bless you, plus 40, bless you, which is 200. Is this mine or yours? Is there any other homework questions over 3-2? Okay. Well, we're gonna stop there today. Sound good?
Yeah. Sounds great.